Do we have any questions, any queries from yesterday's session? Is everything clear from yesterday's class? No questions, no queries? Zoya, Ibrahim, Ahmed, Ryan, Shafi?
No.
Okay. So let me know if the screen is visible.
Yes.
Okay, let's do a few questions. This is related to yesterday's topic. The relative atomic mass of an element is the average mass of the isotopes of that element compared to another particle. Which particle is used for this comparison? You may write your answers in the chat box. What is the relative atomic mass of an element Yes, good. B is the correct answer here. It is basically compared to the carbon 12 atom. Why? Because it has exactly 12 units as a mass. What is the relative formula mass of ammonium nitrate? Relative formula mass is basically used for ionic compounds. So what is the relative formula mass of ammonium nitrate, which is NH4NO3? You may use the periodic table for this one. What is relative formula mass? How do we calculate it? Yes, how do we calculate relative formula mass? Yes, Ryan.
We add up each of the atomic masses of each element,
Each atom,
each atom, sorry.
which is present in this particular compound. Okay, very good. So here we have two nitrogen atoms, which is going to be 2 times 14, which is the relative atomic mass of nitrogen. Hydrogen is 4, which is a relative atomic mass of hydrogen is 1. So 4 times 1. And then you have 3 oxygen. So 3 times 16. You're going to sum it up. Whatever the answer comes up is going to be your final answer. Here, the correct answer is 80. Good. Which equations are balanced? Is it A, B, C, or D? Did you mention B, Ryan, for question number 3?
Yes, Miss, I was typing the answer to the last question and I forgot to delete it.
Okay, okay. Okay, so Ryan chooses B. What about the rest? You have to look into all the atoms. They should be equal on both the sides, the reactant side and the product side, your left and right hand side, basically. Yes, write your answers in the chat box. Okay, if you look into the first equation, there is two iron atoms on the left in iron oxide and two iron atoms on the right hand side as well. Then you have three oxygens here, three oxygens here. Okay, this coefficient 3 is basically multiplied to all of this, okay, the carbon as well and the oxygens as well. So a total of 6 oxygen atoms are basically present on the left hand side. Okay, what about carbon atoms? 3 carbons. This coefficient 3 is again multiplied to everything which is present after it, okay, or adjacent to it. So 3 carbon atoms here and 3 times 2 becomes 6. So this means 6 oxygen atoms. This means this equation is completely balanced. So if you know that equation 1 is completely balanced, the next thing you're going to do is either check equation 2, or next you can check, if you see that equation 2 is not balanced, it is not chemically balanced, just go to equation 4, because we know the answers would be either A or B. You're simply going to nullify option C and D. Okay, you're going to eliminate it. Then you look into the next one, zinc, one zinc atom here and one zinc atom on the right hand side. Then you have one carbon, three oxygens, two hydrogens, and two chlorine. So two chlorine, and we have one carbon and a total of 4 oxygens and 4 hydrogens. We need 2 hydrogens and 3 oxygens. So this is not balanced. This means the fourth one is going to be the correct answer. So as a result, you're going to go with option number uh, 2, that is 3B. Okay. Are we clear so far? Yes, are we clear about this one? Let's move on to the next one. A compound with the formula of XO2 has a relative formula mass of 64. What is X? Use your periodic table. Grab your periodic tables. Okay, Rayan says D. Why, Rayan?
Because if there's two oxygen, that means 16 times 2. 16 times 2 is 32.
Hmm.
And 64 minus 32 is 32. And the, what's it called? The element with an atomic number of 32 is,
Atomic mass of 32, not atomic number.
yeah, atomic mass of 32 is sulfur.
Is sulfur. Yes, that's right. Good. So we go with option D. That is correct. Absolutely good. Okay. Moving on to the next one. The relative atomic mass of an element is determined by comparing the mass of one atom of the element with mass of one atom of element Q. What is element Q? Carbon is the correct answer. Here we just did this kind of a question. Let's move on to the next one. What is the relative molecular mass of sulfur dioxide? Relative molecular mass is basically the terminology which we use for the molecular masses of covalent compounds. Okay, formula mass is used for ionic compounds. Yes, what is your final answer? Zoya, did you mention D for this one?
Yes.
Okay. Yes, that is right. We're basically going to sum up all the relative atomic masses of the atoms which are present in that compound. One sulfur is 32. Oxygen is 16. How many oxygens do we have? Two oxygens, so 16 times 2. Summing up will give you the relative molecular mass for this compound, which is going to become 32 plus 32 will be 64. Hence, D is your answer. Okay. Moving on. This question, I think you will need to look into the molar concept first, and then you have to go to this one. Which information is needed to calculate the relative atomic mass of an element? Is it A, B, C, or D? Yes, good. C is the correct answer. The mass number and the isotopic abundance. The mass number is required, and the isotopic abundance is you multiply both of them with their relevant mass numbers, and then you're going to sum it up, and then if you have percentage abundance, then divide it by 100 to find out the final answer. Then the next one is, I think, again a repeated question. Let's move on to another one. Okay, is a new PDF visible?
Yes, ma'am.
Okay, the equations for two reactions, they are shown to you, equation 1 and 2. Which row shows the value of X and the value of Y, and the equations that are for redox reactions? Redox basically means reduction and oxidation. Okay, redox reactions are those reactions where reduction and oxidation reactions, both of them simultaneously take place. What will be the values, and which ones do you think is redox? Okay, Hamdan says D. What about the rest? Okay, Zoya, elaborate on your option choice. Why do you choose C here?
It's because I already know the equation 1 is a redox reaction since
Okay.
carbon is gaining oxygen and carbon dioxide is reducing an oxygen.
Mhm.
But for equation 2, the C2H6,
Mm. The carbon is gaining oxygen.
Yeah,
Hmm.
I don't really know about the redox reaction part.
Okay. And what about values of x and y?
Yeah, X is 2 and Y is 6.
X is 2, y is 6. We basically put in these values, and then we get to know that if you write 2 as a coefficient with x here, it is going to become 2 carbon atoms and 2 oxygen atoms, which is completely balancing the left hand side of the equation. If you look into equation 2, in equation 2, we have to look into y, the value for y. And there are a total of 12 hydrogen atoms on the left. So to make it 12, you need to add in 6 here. This 6 will be multiplied with this 2 to give you 12 hydrogen atoms. Okay. So this means that it wouldn't be A or B. The answer is either C or D. Okay. All of these options, they have one. Okay. Now you have to look into the equation number 2 for whether it is the redox reaction or not. Okay. Let's look into this. Here, basically, the basic concept of redox is we will do it separately, but just giving you a gist here. Redox reactions are those reactions where reduction and oxidation, both of them simultaneously take place. Okay, one particular species is getting reduced and the other one's getting oxidized. So that is where you get to know that this particular reaction is redox reaction. In the first equation, if you see, the reduction and oxidation can be expressed in terms of either gain or loss of oxygen, okay, gain or loss of hydrogen, gain or loss of electrons, and their changes in the oxidation state. Okay, if any particular substance is decreasing its oxidation state, it means it is getting reduced. If their oxidation state is increasing, this means they are getting oxidized. Don't get confused. We're going to discuss this in redox, but here just to clarify this question, the if you look into this, in carbon dioxide, the oxidation number is +4. Okay, but here in carbon monoxide, the oxidation number changes to +2. This means that this is a decrease in oxidation state. Whenever the oxidation state decreases, okay, it means that this particular substance has been reduced. So what is reduced? Carbon dioxide is reduced to form carbon monoxide. This means this is a redox reaction. Okay, and if you look into the next one, and carbon is also gaining oxygen, right? So if you look into the next one, equation number 2, here again carbon is gaining this oxygen to produce its own oxide. Hydrogen is gaining this oxygen to produce their own oxides. Okay, water is being formed, carbon dioxide is being formed. This means that this particular reaction is also redox. Okay, so we're going to go with option D. Option D is the correct one in this case scenario. Are we clear so far?
Yes, I didn't understand the redox part.
You didn't understand redox part. Can you particularly ask me what is still not understood?
I didn't understand from where you got +4 and +2, and even if you did, didn't you say that redox should be oxidation as well as
And
reduction?
reduction, yeah, of course.
So where is
If
the
you see,
oxidation?
if you see this carbon dioxide is getting reduced. Why? Because the oxidation number is decreasing. Now look, in carbon dioxide, what atoms do we have? Carbon and oxygen. Okay. The oxidation number should be equal to 0 according to the rules of oxidation. Okay. We will study this particularly in redox. If you say that I don't know the oxidation number of carbon here, okay, you have to find it out. Oxygen's oxidation number is -2. Why? Because oxidation number is particularly determined by the loss and gain of electrons. It needs to gain 2 electrons. So the oxidation number becomes -2. You multiply it by 2. Why? Because you have 2 oxygen atoms. Okay. When we add these both of these oxidation numbers, the oxidation numbers of both of these elements present here, it should be equivalent to 0 for all the compounds. For all the molecules, for all the compounds, it should be equal to 0. This is the rule of oxidation states. Okay. So overall, a compound, a molecule has an overall 0 oxidation state. So to sum it up, it will become 0. All right. So this is again, X is the value for oxidation state of carbon. Here it is basically -4. Then you're going to switch it. You will take this on the other side. This becomes, so X becomes +4. This means that the oxidation state for carbon here is +4. Is this point clear so far?
Yes.
Okay. What about carbon monoxide? When you look into carbon monoxide, is this again a compound? Yes, it is. So its oxidation number also should be equivalent to 0. If this is -2, this should be +2 to make it 0, right?
Yes.
This means that the oxidation state has been decreased of carbon. Whenever the oxidation state decreases, this means it is particularly reduced. This means that carbon dioxide is reduced. Okay. Or particularly carbon element here in this case scenario is reduced as it is changing its oxidation state. Is this point clear so far?
Yes.
Okay. When you look into the next one, the carbon element. The carbon, whenever any particular substance is in its elemental state, it is not yet combined with any other element. Then we say that its oxidation number is going to be 0. Okay. When it is not yet combined with any other element in its elemental state. From carbon, it has formed, on the product side, it has formed carbon monoxide, and the oxidation number here is +2. Is this oxidation number increased?
Yes.
When the oxidation number increases, we say that oxidation has taken place. Okay. This means that carbon element has been oxidized and carbon dioxide has been reduced to form carbon monoxide. Is this point clear so far? Both of these substances, they have reduced and been oxidized simultaneously. As a result, we say this particular reaction is a redox reaction. Clear?
Yes.
Okay, just give me a minute, I'm coming. Okay, let's move on to the next question. Methane burns in air to form carbon dioxide and water. What is the balanced equation for this reaction? Is it A, B, C, or D? You have to look into the state symbols as well. Okay, Ibrahim and Rayan says B. Yes, B is the right answer. Good. Okay. Moving on to the next one. Magnetite is an ore of iron which contains iron 2 plus, 3 plus, and O2 minus only. What is the formula of magnetite? Yes, what do you think the answer should be? Is it A, B, C, or D? Okay, Zoya says B. Why, Zoya? Why do you think B is the correct answer?
Because if we take iron Fe2 plus and oxygen 2 minus, it will cancel out each other, which will give us FeO, but we don't have that in the option. So then we'll take Fe3 plus and O2 minus. So like when we like crisscross them, so it will give us Fe2 and O3.
But they say that this particular iron ore contains Fe2 plus and Fe3 plus and also oxide ions. This means that both of these particular ions of iron 2 plus and Fe3 plus and Fe2 plus, both of them they are present. Okay, this is a different kind of a question. This is not the usual questions which is usually asked in papers. Okay, let's look into this. They say that all of these ions are present in this particular iron ore. Okay, and then they're asking you, what do you think will be the formula for this? Whenever we need to find out a formula for any of these, for any compound, basically, the charges, we know that the oxidation state should be completely zero, right? For a compound, the sum of all the oxidation states should be zero. This means that your positive and negative charges should balance out each other on both the sides. Okay. When you're going to look into this means that the compound, since the compound is completely neutral, you should have equal number of positive charges and equal number of negative charges. All right. Let's look into this. For instance, if you take iron and oxygen, they are this is +2 and oxygen is -2. This means that their ratio is 1:1. Okay. Both of them, if they are present, then it should be 1:1. All right. Why? Because this is one iron which is completely balancing out one oxide ion as well. Similarly, if you look into Fe3 plus and oxide ion, what do you think? How many iron ions would be required to balance out oxide? Yes, this should be 2 and this should be 3. Okay, there should be 2 and this should be 3. The ratio becomes 2:3, right? Yes, hello. Are you all able to hear me? Okay. So, how many Fe3 ions are present and how many Fe2 ions are present? A total of 3. Okay. And how many oxides are present? 3 plus 1, a total of 4. So the ratio becomes 3:4. In other ways, you can also check out their charges. Positive ions are these. 2 times 1 is 2, 3 times 2 is 6. So our positive charges are +8. 6 plus 2 is 8. How many negative charges do we have? -2 and this -2 times 4, which is going to become -8. Okay. All right. A total of how many oxide ions were present? 4, right? 4 times -2 is -8. So a balance of the positive and the negative charges is present on both the sides. This means the ratio of Fe to oxygen would be 3:4. So option B is the correct one here so far. Are you getting my point? Since the compound is completely neutral. Is this question clear to everyone so far?
Yes, miss.
Does anyone need any explanation regarding this? Is this clear? Okay, let's move on to the next one. Which formula is an empirical formula? What is an empirical formula? Yes, Ryan.
An empirical formula is when the ratios of all the atoms in a compound are like as simple as possible.
Yeah, the simplest whole number ratio. They should be all simplest whole number ratio. If your answer is coming up in decimals or something, then it is not accepted. So all the atoms should be in their simplest whole number ratio in the empirical formula. That's right. Good. So your answer, both of you say, Rayan and Zoya say A. This is correct. That this is the simplified ratio of carbon, hydrogen, and oxygen which is present. Hence, this is referred to as empirical formula. This is not an empirical formula, this is not an empirical formula, and this is a molecular formula. Okay. Moving on to the next one. Which equations do you think they are balanced? I think this is a repeated question. Yes? Look at the next one. Aqueous iron 3 sulfate and aqueous sodium hydroxide react to give a precipitate of iron 3 hydroxide and a solution of sodium sulfate. What is the balance symbol equation for this reaction? Is it A, B, C, or D? Yes, good. C is the correct answer here. All the atoms are balanced on both the sides. Also, if you look into the state symbols, both of them, they are aqueous. It is given to you in the context of the question. Aqueous iron 3 sulfate and aqueous sodium hydroxide. They react to give you a precipitate. Precipitate is insoluble, which is why it should be a solid. And then a solution of sodium sulfate is formed. This means that it will be aqueous. So C here is the correct option so far. Moving on to the next one. Sodium nitrite contains the nitride ions, that is N3 minus, which is unstable and decomposes into its elements. What is the equation for the decomposition of sodium nitride? Yes, good. B is the correct answer. What you're going to do here, sodium nitrite contains the ion. This means that this is an ionic compound. Sodium is Na plus, nitrite is N3 minus, which is given to you in the question paper. Then they say that sodium nitrite is unstable, so it decomposes to form its elements. This means in elemental state, it should be sodium and nitrogen molecule. Okay, it is a diatomic molecule, so it wouldn't be an atom. Okay, this means option D is completely eliminated. What is the equation for the decomposition of this? When you find out the formula of sodium nitrite, it becomes Na3. You're going to swap and drag the valencies, and 1 plus comes here as a subscript. 1 is usually not written. If you look into this Na3N, we only have one particular equation, this one and this one. We have eliminated D as our answer choice, so B would be the correct answer. Then you should chemically look into this, whether this equation is balanced or not. What is the empirical formula of X compound? X contains a carbon, hydrogen, oxygen only. By mass, it contains 26% of carbon and 2.2% of hydrogen. What do you think will be its empirical formula? When you have such a question where carbon hydrogen is percentage is given, you know, and you don't know the percentage for oxygen, what should you be doing? You're going to subtract the sum of these two carbon and hydrogen elements from 100%, which is taken to be the whole. Okay, so 26.7 minus 2.2, or you can simply sum this up and subtract it from 100. What will be the answer for this one? 26.7 plus 2.2 and 100 minus that.
71.1.
71.1. Okay. So this is basically the percentage of oxygen. All right. Now we're going to write down carbon, hydrogen, oxygen. Their percentages are to be written 26.7, 2.2, and 71.1. Okay. Next, what you're going to do, divide all of these percentages by their relative atomic masses. That is 12, 1, and 16 respectively. Okay. Tell me the answers one by one. 26.7.
2.225. 2.225.
2.225. Okay. What about the next one? 2.2. And the next one?
It's 4.44375.
Okay. So 4.444. Okay. Now you're going to figure out which one is the smallest number. 2.2 is the smallest number, right? You're going to divide all of them by 2.2. What do we get?
We get 1.01.
1 point.
It's like a long number. When you round it up, it's 1.01.
1.01. Okay. The next one is 1. The next one is
2.01. No, actually, yeah, it's 2.02.
2.02. Okay. Now we still see, we are able to conclude that carbon is 1, this is hydrogen is 1, and oxygen is 2 approximately. Okay. As a result, what should be your answer in this case scenario? Should it be A, B, C, or D? According to
D.
these ratios, the answer should be D. So we're going to go with option D, which is CHO2. Which word equation represents a reaction that occurs? For this, you should know the reactivity series. Yes, pass it. Okay, Zoya
Yes,
says
miss.
D. क्या है इसका आंसर क्या है पास it?
One minute, miss.
Okay. Hamdan also says D. Very good. The more reactive element or the more reactive metal is going to displace the less reactive one.
B.
C or D?
B.
B. You going with sodium oxide reacts with iron to form sodium and iron to oxide?
Sodium is more reactive, right?
Yeah. So do you think that iron can displace sodium from its oxide?
No.
No. So B shouldn't be the answer. Copper is less reactive. Iron is more reactive. So the copper can also not displace iron in this case scenario. In the
So
next
answer will
one,
be D.
answer is going to be D. Iron 3 oxide reacts with carbon to form iron and carbon dioxide. Carbon is more reactive than iron, so it is going to displace iron from its oxide. As a result, it will be reduced to form iron and carbon oxidizes to form carbon dioxide. Okay. Look at this one. Aqueous iron 3 chloride, FeCl3 reacts with aqueous potassium iodide, which is Ki. These statements you think are correct? In the valence equation WVXY, they have the same value. A potassium iodide is an oxidizing agent. Oxidizing agent is basically a particular substance which itself gets reduced and facilitates or helps the other substance to get oxidized. What does agent means? Agent basically allow us to do something, or they facilitate the other compound to do something. So this oxidizing agent is basically facilitating the other compound to get oxidized. However, itself gets reduced. Okay. A dark brown solution is produced in this solution. Which ones do you think would be correct?
Miss, what's the oxidation state of chlorine?
Of
Chlorine.
Chlorine, what do you think would it be? -1.
Okay.
It is basically the amount of electrons it has lost or gained. Okay, chlorine is in group 7, so it is going to gain 1 electron. So the oxidation state tends -1. Okay, Zoya says G for this one, and Hamdan. Why do you think, Zoya, D is the correct answer here?
No, miss, I just realized it's wrong.
Okay. All right. So which statements do you think they are correct? In the balanced equation, V, W, X, Y, they have the same value. Now, if you look into this, we have iodine only here in this case scenario, okay, on the right hand side, which means this is 2 and there's no coefficient which is attached with it, right? The no adjacent coefficient. This means that this W has to be 2. If this is 2, this is 2, and this is 2, all of them, they are of same values, then is the equation completely balanced? Let's check. So 2 iron, 2 potassium, 2 potassium, 2 chlorine, and 4 here. So 4 plus 2 is 6. 3 times 2 will become 6 chlorine atoms here on the left, and 2 iodine atoms. Okay, so 2 iodine atoms on the right as well. This means that yes, after having all of them, if they possess same values, then the equation is chemically balanced. Okay. So this means this first statement is completely right. Now we should check statement number 2 and 3. Your answer will either be A or B. All right. Potassium iodide is an oxidizing agent. This means that it should be getting reduced. Okay. Potassium iodide is a reducing agent. It cannot be an oxidizing agent. One. The second thing is, if this needs to reduce, this means that FeCl3 should get oxidized. Is FeCl3 being oxidized? Let's check. Iron here has an oxidation state of +3, and here it has an oxidation state of +2. There is a decrease in oxidation number. Is this being oxidized or being reduced? It is being reduced. So this means potassium iodide cannot be an oxidizing agent. And particularly speaking, potassium iodide is actually a reducing agent. Let's move on to the next statement. Now you still know that your answer is basically B, that is 1 and 3. If you're short of time, you can simply go with this option choice and then move on to the next question. But when you are able to look into it, then just read the statement. A dark brown solution is produced in the reaction. Yes, this is correct. Why? Because iron is produced. This iron is basically dark brown in solution form. Okay. It has distinctive color states. We will do this in halogens, okay? But for now, this basically has a dark brown solution when it is produced in the product side. So the correct answer here in this case scenario is going to be B so far. Are we clear?
Yes, miss.
All right. So this is the end for today's session. I think you guys have might have another class. So take care, Allah Hafiz. Thank you. We will continue tomorrow.